All right, before we get into the exciting world of public data records, we'll dig into a little bit of background to understand the why we built what we did, and a little bit of history lesson, because when I stepped into the project, I had no idea about any of this information, and it was very important to understand the context. So in 17 states in the US, they have completely deregulated energy markets, and in California is not one of those. It was a completely foreign concept to me. What this allows to happen is allows consumers to shop for residential electricity plans for their house, apartment, trailer park, condominium, what have you, similar to a cell phone plan that is completely decoupled from the actual utilities that have the wires and electrical meters to the houses. And within these markets, Texas is by far the largest market for residential electricity plan shopping in the United States. And within these deregulated states, there are licensed brokers that are allowed to resell electricity plans and earn sales commissions. They're to be fully vetted by the regulatory bodies of the states, and they operate much like a super affiliate model, but they are highly regulated and overseen by government agencies, plus they must be approved by each and individual electricity providers. And within this model of earning sales commissions on electricity plan shopping, there are two primary sign-up options on these third-party websites. They're either traditional link-off style, where you go to the provider's website to then sign up for an electricity plan, and then you earn your sales commission. And then the second one is through API-based checkout, where you actually have to create a custom cart, and you sign up on the third-party broker site, completely registered through there. The API data is passed back and forth from the third-party site. The complete sign-up process happens on site, and then the earned sales commission. It's important to note, which we'll talk about later, is that through our testing and findings of working with this client over a long period of time, the on-site API checkout had an average conversion rate difference of over 40% higher, and which increased almost double revenue for the same group of site visitors when you had API checkout enabled. So now, step into 10-up client called Electricity Plans. And they operate out of Texas. You can go to their site, electricityplans.com, which I believe they probably paid a very hefty penny for that domain name. And they primarily focus on the Texas electricity market, even though they do have presence in 2 other deregulated states. And they actually operate in 4 other states as well for natural gas plans. But because, at least in Texas, electricity plans or electricity usage is about 95% of the annual utility bills in most people's houses because of the heat. The MVP version of the site, every single provider plan was a complete link-off style, where they would drive traffic through paid ads, organic search, other marketing and advertising avenues, and go to the site, they click the sign up button, and they would basically disappear into vapor at that point, and they had no control over the rest of the conversion process, because most electricity provider sites are 10, 15 years old and horrible UX. Many of them were not mobile friendly, and some there was even issues with cross-domain link tracking because they would get redirected to an M.dot subdomain, and the client was losing out on commission sales with no way to accurately validate it. And so overall conversion rates on these link-off sites are less than ideal and not sustainable as a business for the long run. So the vision for the version 2 of the site was to integrate an on-site API-based checkout into the WordPress site. As we dug into what that meant as far as our discovery and research, we found that within the state of Texas, every single electric meter, and we're talking in the over 20 to 30 million electric meters, all have a unique identifier. And this identifier is chip-based enabled, allows to operate over cell phone networks, which is what allows the technology for shoppers to register through a new plan through a third-party website or electricity provider website, and on a particular date and time of that API request, when it's finalized, that the switch is thrown, and now the people serving electricity to that house now changes. And it's all through this smart meter technology, and only exists in the state of Texas. So that component is a required piece of data that you need for the API-based checkout, plus you need a valid address for that building. So it's almost like 2-factor authentication for the unit itself. One thing that we found, there's actually no readily available source of this electric meter data anywhere. There's no third-party software as a solution, get ESID data for the state of Texas that you can just go sign up for as a service. And we scoured looking for one to try to shortcut this. And then what we found, so we tabled that idea and figured out, okay, we'll come back to that one. Let's start digging into address lookups because we need an address lookup service. And as we all know, there are numerous third-party address lookup services, but what we found after testing at least half a dozen was that the data structure that they returned from their third-party lookup requests were incompatible with the electricity provider's API requirements, and this third-party address data, the format was often incompatible with things like apartments, unit numbers, space numbers, and they used very different nomenclature. So if you think about Google Maps, if you looked up an apartment building, whatever address it was, they don't actually define down to the actual unit number. But we need the actual unit number and the part of the address, and that unit number has to be isolated as a separate integer. Otherwise, it breaks the API request when we're trying to send this data. So between the two, we discovered that because there are basically no solutions, we have to build our own. And the idea is a completely custom database that contain every address and electrical meter in the state of Texas. So, and when you think about that, think of a town like Austin, Texas, and it's one of their larger cities. Think about every single nail salon, hardware store, apartment, unit, just alone in one high rise, and how to deal with that much data at a scale that is statewide Texas. And then think about West Texas, out in the middle of nowhere. If you've ever been there, you can go for an hour and not see a single person, but every single one of those electrical meters has a unique identifier, and the only way that those people can shop for electricity is with that number. And we found that there is one source of data where this actually does exist, and it's through ERCOT, the Electric Reliability Council of Texas. And this is the governing body that oversees the deregulated electricity market in the state of Texas. And we found through their data set that there is well over 20 million records for every single unit within the state of Texas. This information, unbeknownst to me, is updated every single night as the electric status of every unit in the state of Texas changes constantly as people decommission, as they move. You think how often you change electricity service or move? Once every few years. But if you imagine at the scale of the site of Texas and how many people are switching apartments or moving, or they don't pay their electric bill and get shut off, that information is updated at a grand scale every single night. That information was available only through CSV files. And we thought, okay, well, that's not super usable in the beginning. So we dug into, they had some loosely documented API access that was only available to their approved market partners. So we worked with the client to get them established as a market partner with ERCOT in the state of Texas. And we were granted API access, which is awesome. We thought, oh, great, we don't have to build anything now. We've got API access. It turns out, once you're a market partner and you have API access, all they give you is API to download the same exact CSV files. And within those exact same CSV files, for the API access, they have horrendously complex security and authentication rules with certificates that we had to install on the engineer's machine just to be able to access the API. Plus, you had to define static IPs. And as we started building out the functional requirements, we realized that the infrastructure to maintain this data through their API that was just a CSV file was going to be horrendously expensive in the long term and cost prohibitive for the client to invest the kind of money that we need just to build it in the first place. So as I indicated earlier, after we've gone through this exercise of becoming a market partner and gaining full API access to the data, the exact same data is available at publicly available URLs and the same exact update period of every single night. And like I said, there's no authentication required. There's no rate limiting on the downloads. So we saw this as an opportunity to completely abandon the API access to the data and build an automated daily process to scrape the page, download the zip files, unpack them, and parse the CSV files. And on the technical side, we utilize AWS Lambda resources because the only process runs about 1 hour every night. A custom Node.js app spins up, unpacks these files, parses the data, does some data validation, strips out a bunch of data that we know we don't need, and then this data is then converted into a scalable database within AWS storage. I think it's RDS, if I remember correctly. But at this point, now we have this solution that we built that took a while to figure out how to get there, that we have this giant database of electrical meter and address data. That's great. It's updated nightly. But now we need to do, how do we access this data in a performant way? How do we make this compatible with WordPress? What's the next step in this challenge? So from our scalable database storage on AWS, we then sync that data after the data import process happens every night into a managed Elasticsearch instance, which those not familiar with Elasticsearch enables very fast performance search and allows it to parse through huge amounts of data. Just so happens that 10up has an open source solution for connecting Elasticsearch to WordPress called ElasticPress, and we do have a managed service called elasticpress.io for hosted Elasticsearch service. Didn't bring any coupons with me tonight. I feel like I should have after the last couple of talks. And so using our knowledge and our experience from working with Elasticsearch and WordPress, we built a custom integration between this, between WordPress, utilizing some of the code from our open source version of ElasticPress to connect to our custom database. And what this allows to do, the end result allows the lookup service that we custom built for someone to search by address, and a thing that we did not even consider was the electrical meter ID itself, which after a bit of research and discovery in collaboration with the client, there are scenarios when addresses don't yet exist. New construction, when a building is being subdivided, or somebody knocks down a wall, like in a condominium, and combines it to one unit, both original smart meters go away and a new one goes away before the address is finalized within the Postal Service and then updated to ERCOT. So the API needed to work two ways. And the only way we could do that in a performant manner was utilizing Elasticsearch infrastructure. And within the Elasticsearch integration into our custom database, we also enabled autocomplete to minimize any errors. And with the autocomplete to minimize errors, we bypass the problem of inconsistent data structure with unit numbers, apartment numbers, hash signs for building numbers, all the varying inconsistencies that people use to denote things other than individual standalone houses. So the end result of the work and integration into WordPress, this is a screenshot of the checkout page of once a customer selects a plan and they're into the first step one of the checkout process. We have constantly up-to-date address and ESID data that's updated every single night, and the data accuracy is extremely high, as there's only one source of data, because all the third-party electricity providers also use the same source of data in their address verification and electrical meter lookup service. So as a provider, we were able to use the same source of data that our client is validating against. And because we now control the data structure, the results that we are making with the API requests are fully compatible with the electricity plan provider APIs. And because we used Elasticsearch, we get near instantaneous lookup through 20 million records that are constantly changing. And there's a sample of the first string is the address, and then the second string after the pipe is the 17 to 22 digit electrical service meter ID number. And unbeknownst to me, there are actually people in Texas that know their electrical meter ID numbers, because they are what they call them super shoppers that change their electricity plans like every 2 to 3 months, constantly tracking the best deals, where some are 3-year plans, some are month-to-month plans. And so they have they actually have their IDs memorized, which I found fascinating. Long-term results, what it meant for our client was they have been able to convert all of the MVP link-off providers to API-based checkout one at a time. Within the Texas electricity market, there is API-only providers that do not even provide that option. So until we had a system built that allows them to have the electrical service lookup and address lookup service available, they were not even allowed to partner with these additional providers. Now, because it's available, they get partners calling them asking to be on their site. Because we're utilizing the AWS Lambda for processing resources and storage, the infrastructure to host this custom database is very affordable for the client on a monthly basis, because we're only using these processing powers for little under an hour per night, and the rest is mostly static storage, and then Elasticsearch storage is pretty nominal. And what's most important, since we've implemented this system for the client, they've seen month over month consistent revenue increases, and their conversion rates have gone up anywhere from 30 to 45%. And they continue to keep growing just through organic efforts and having a better on-site user experience than linking off to third-party provider sites. And that's my talk. Any questions? Brian Bourn. Thank you. Got time for 2 questions. We don't hold up happy hour.
Is there a standard?
There's no standard whatsoever. So as far as how we handle it, we actually built a very an abstract class to interact with all the APIs, and then we have sub-modules to deal with every single separate one, because some are SOAP, some are REST, some are XML. There was one, it was a completely homegrown all through HTTP requests. So everything is done through sub-modules that interacts with the abstract class, which then interacts with our universal front-end checkout system that we created and built. One more. All right, thanks so much.